Mobile robots are, of course, mobile robots that move from one place to another place, but that the whole robot moves. I mean, every robot moves, but in typical industrial actuators, they have their base fixed on the ground, and they only move, let's say, the arm. When we speak about mobile robots, the whole robot moves. We exclude teleoperated robots, and we exclude them just because I don't think they are really robots. If you remember in the first videos of the robot nodes, when we were trying to identify the traits of a robot, one of them was that a robot was autonomous. And if a robot is teleoperated or a device or a machine is teleoperated, that machine is not really autonomous, despite they might have sensors, actuators, structure, and physical appearance very similar to what we call a robot. And finally, we will also exclude humanoid robots, not because they are not mobile robots, they are, but they are a very special case of mobile robots, so I prefer to treat them apart. I'm thinking specifically in what are called AMR, autonomous mobile robots, that are typically boss-like robots, like our old friend Themium, and you can find them in structured environments such as warehouses. For example, the Kiva robot of Amazon, or perhaps in within fields, or perhaps we could be speaking about rovers for spatial exploration or the like. Special cases of mobile robots could be considered autonomous drones, autonomous vehicles, or robot dogs. Old fashions or the first mobile robots were of the type that were called AGV, auto-guided vehicles. In this kind of robots, the path they have to follow was marked via an electromagnetic signal emitted by an underground cable. But modern mobile robots are really autonomous. They don't use a cable, but they navigate. And in order to do so, they have to solve, let's say, four topics. First of them is that navigation. That is how to calculate the optimal trajectory, the optimal path, and how to follow it. That's global navigation. And local navigation that has to do mainly with obstacle avoidance. But to help that main objective, navigation, they have some helping techniques. For example, mapping. That is building or acquiring a map of the environment where the robot is to move. Or odometry that use proprioceptive sensing that base it on a wheel movement, knowing how the whole robot is moving. And finally, localization, that is knowing the position, let's say the absolute position, sometimes relative, but usually absolute position of the robot using things like geopositions or perhaps beacons or markers. All these four topics are interesting by themselves, and so we'll devote a specific video to each of them.